Welcome to part 2 of section 6.1, the law of sines. Today we're going to be talking about the ambiguous case. Now, because the angle is not included between the two sides, it doesn't lock the shape in enough to determine whether the triangle is going to necessarily be an acute triangle or an obtuse triangle. And there's also a possibility that the triangle doesn't exist. So that's why it's called the ambiguous case. It leads us to a couple issues. So we could have no triangle at all. We could have only one triangle, and we could have potentially two distinct triangles. So we have to consider that as we're going through. So when we have this, when the triangle is acute, we could have side A, opposite angle A, being less than the height. That would be no triangle. When they're equal, we would have one triangle. And when A is greater than B, we would have one triangle. When the height and the base, or I should say side A, is in between the height H and the side B. We could also have it where it's obtuse. So we have a lot of things to keep referring back to. So now, for the following scenarios, we're going to find all the missing sides and angles if the triangle even exists. So when I set this up, we have side A, side B, and angle A. Now, I'm going to draw it as an easy way to make it look like our situations above. Here's angle A. It's 42 degrees. Now, I'm not going to connect them because I don't know if they even connect. So here is side A, which is 22. Let's make this angle B here. Let's connect them. Why not? And side B is 12. So looking at the scenarios above, we have those two sides. Now looking at it, we see this case where A is greater than B. So we have one triangle. So now we can use our law of sines to find the missing sides and angles. So now, A over the sine of A equals B over the sine of B. I'm going to start there because that's the information I know so far. So A over the sine of A. So it's going to be 22 over the sine of 42 equals 12 over the sine of B. So what we would do is we would cross multiply. 22 sine B equals 12 times the sine of 42. We would divide both sides by 22, and the sine of B equals 12 sine 42 divided by 22. Now we need to find the measure. To find the measure, we're going to take the inverse sine of both sides. So angle B is going to be the sine inverse of 12 sine 42 over 22. So angle B is going to be about 21.41 degrees. Now, angle C, it's a triangle. So we know that angle C is going to be 180 minus the sum of the two angles, 42 plus 21.41. So angle C, when we do that, 116.59 degrees. So this is actually an obtuse triangle, obviously because we have an obtuse angle. And now we need to find the length of side C. So we can still use our law of sine. So A over the sine of A equals side C over the sine of C. So we have 22 over the sine of 42 equals C over the sine of 116.59. So what we can do is multiply both sides by the sine of 116.59. So side C is going to be about 29.40, which makes sense because that's opposite the largest angle. It should be the largest side. All right, let's go to the next page, and we'll keep referring back to this. Given side A is 15, side B is 25, and angle A is 85 degrees. Now, I'm just going to kind of sketch just to help me out. A, so the opposite, and angle B. So the opposite of A, here's our 85 degrees, this is 15, and this is 25. Now, looking at this, going back, do you see how we have this case where A is less than or equal to B right here? What's going to happen is we're not going to have a triangle. Now, we can find this another way because that's if it's obtuse. What if it was an acute? What we could do is we could find H. So now let's find H just to make sure. So we have the sine of A equals H over 25. So the sine of 85 equals H over 25. Multiply both sides by 25. H equals 24.9. And you can see A is less than H. So there is no triangle. There's no triangle here. We can't solve for anything because it doesn't even exist. Now let's say you didn't recognize any of that and you did try to find this triangle. So let's say we did that. So we'd have our law of sines. A over the sine of A equals B over the sine of B. So you have 15 over the sine of 85 equals 25 over the sine of angle B. Cross multiply as we've been doing. 15 sine B equals 25 sine 85. Divide both sides by 15. The sine of B is 25 sine 85 over 15. And then take the inverse of both sides. So angle B is the sine inverse of 25 sine 85 over 15. And when you type that in your calculator, you see it doesn't exist. You get a domain error. So there's an error, doesn't exist. Once again, if you get an error like that, there is no triangle. So that's a case where we have no triangle. And let's go to the next one. We'll set it up the same way. Angle A, or side A, side B, and angle A. I'm just going to connect it just to help me draw. A, I'm going to put in that corner 20.5 degrees. Side A is 12, B is 31. Now, we need to find H. When this side is less than this side, we need to find H. So to find H, the height, the altitude, we have the sine of 20.5 equals H over 31. So H equals, when you multiply both sides by 31, H is going to equal about 10.86. So now, H is 10.86. So H, the 10.86, is less than A, which is 12, and is less than B, which is 31. So looking back at our examples, when A is between H and B, there's our case. We have an ambiguous case. We have two potential triangles, and we need to find both. So, two triangles. So now, using our law of sines, A over the sine of A equals B over the sine of B. So we have 12 over the sine of 20.5 equals 31 over the sine of B. Cross multiply, you get the sine of B, 12 sine B, equals 31 sine 20.5. Divide both sides by 12. The sine of B equals 31 sine 20.5 over 12. And then we take the inverse of both sides, the sine inverse. So the measure of angle B is 64.78 degrees. So now to find C, angle C is going to be 180 minus the sum of 64.78 plus 20.5. So in that case, angle C would be 94.72 degrees, and we'd have to find the side C. Here's angle C, here's side C. So we would have C over the sine of C equals A over the sine of A. Excuse me. So you'd have C over the sine of 94.72 equals A, which is 12 over the sine of 20.5. So we multiply both sides by the sine of 94.72. C equals, and when you multiply those, you're going to get about 34.15 units. There's case one. Now, there's a possibility that we didn't find the right pieces. So what we could do is maybe angle B isn't acute, maybe angle B is obtuse. So what we would do for case two, the other possible triangle, we'd have to find angle B, angle C, and side C. So for this, what you would do, angle B, you would take the acute angle and you would do 180 minus what we found earlier, 64.78. So angle B might actually be 115.22 degrees. Meaning that angle C is going to be 180 minus the sum of 115.22 plus or 20.5. Meaning that angle C would have a measure of 44.28, where angle C is the acute angle this time. And then we would find side C using our law of sines. C sine C equals A over the sine of A, using our new values. So what we would see is that C over the sine now of 44.28 equals 12 over the sine of 20.5. So multiply both sides by the sine of 44.28. C equals, and when you multiply, you're going to get 23.92. And there's the case 2 values. All right, and there it is. That is the law of sines. In the next video, we're going to be talking about how we can find the area of oblique triangles.